So if we are to consider this typical question, which is question number two that we are given still working on our waves, sound and light. So we are given the diagram below represents a transverse wave of frequency. So we are given according to the information that we have, that is, we have got a frequency of 20 hertz moving from left to right. Okay, so it is moving from the left going to the what, to the right. So the direction that is from left to the right, right? So the frequency, like I said, it is the 20 hertz. Then it is moving from left to right at a speed of, so we're given the speed, which is 10 meters per second. All right, then according to the diagram and the presentation, you're supposed to know whatever that you're given, try by all means to go through. So I'm going to talk about this term. I discovered from the previous classes that we had the point A, the point A. All right, so the point A, the one that we are seeing at the lowest point of a wave is referred to as the trough. All right, so that's a trough. So I don't know. You see, this guy is waking with a tired mind. I was saying the trough. No, this is trough. Trough. Okay, so that is the trough, which is at the lowest point. The one that is at the maximum values, which is at the highest points, is the one that you're going to refer to as the crest. All right. So, guys, the pronunciation there is the tro. Okay. So, that is what we have. So, for those that have been watching other videos, I think you've been surprised to say, what is it that is happening there? Okay. So, I want you to correct that part and make sure that you have the right thing in your revisions. Okay, so let us try to study. We are given the point A, the point B, as we can see these are inverse, all right, which is fine. Then also we've got the X, all right. What does this X represent? Okay, like I said, from one of let's say we are referring to the points, all right, which is from the crest to another crest. What is it that you form? You form the wavelength. All right, so the X that we are seeing there is the wavelength. So just try to study the diagram that you're given. It can be from this point A to this point, all right, like this. You can refer it that way. Still the same thing. That is our wavelength. Then we have got this Y here, which is taken from the equilibrium position or from the position of rest, taken from this point to this, that is the amplitude. All right, so that is our amplitude. It can be from this point going up. All right, that is, that distance represents what, the amplitude. Then we also refer to the issue of the complete cycles. All right, as you move from this point to this point like this, I said you will be referring to as this movement that you'll be having is from a maximum to a minimum. All right, so we are going to have another one from a maximum to a minimum, like that. Another one, so they will be referred in terms of the quarters as you move from one point to another. So as I move from this point to this point, I'll be referring a quarter, another quarter to make a half, then from this one to this one to make another quarter, then to this one to make another half, like that, and so on and so on. So meaning to say, if we are to consider it properly, all right, let us just say we've got something like this one. We move on like this, all right, up to this point. If we are to consider in terms of the quarters, you'll be seeing that you'll be having a quarter that is covered, another quarter which is covered, then we are going to have another quarter which is covered, then we are going to have another quarter which is covered. In terms of the distance from this point to this point, the distance there from this point to this point, the distance from this point to this point, the distance from this point to this point. It is also important that you take that into consideration. All right. This one is just for your revision, just to consider those distances. They can actually help you in just observing the diagram that you'll be given there. All right. So, anyways, this is not part of our question. It was just going through the diagram. So the questions are direct. In this case, we are given to define the term transverse wave in words. How do you, what is the description of a transverse wave in what? In words. So remember, I referred back that this is a wave. A transverse wave is simply the wave in which the particles of the medium vibrate at right angles to the direction of motion of the wave. So they will be at what? At 90 degrees, that is at right angles. So if you are to consider it's gonna depend, guys, with the way that you define these definitions, guys. They are in your hands. I just want you to see this one. It can also help you in the revision. All right. You can also add this information, just this information. Then we can move on to another part. Then we can move on to another part, at least just the basic. All right, I want you to have the basic there. Just hope this is not gonna affect. All right, all right. Why is it big like this? I just hope it's not gonna affect us, guys. So it's just like this. All right, let me see so that you can put it in the way that you understand. Because as for these definitions, I want you to work out from the understanding that you are having here, then to the way that you understand as an individual. So we have got a transverse wave, which is a wave where the movement of the particles of the medium is perpendicular, that's at right angles, to the direction of propagation of what? Of the wave. We referred this before, so this is just a matter of a recap as you are having your revisions, just a matter of what? Of recap. All right, let us consider another part. We're gonna consider another part. I just hope guys will be able to understand each other here because of this network, guys. Sometimes, these devices, they just tend to misbehave. Okay, anyways, provide the labels. All right. So on the labels, I think I talked about that issue of the trop, which I said you must correct that part, guys. Please make sure that you go through that part. All right. 2.21, that was X. The label X, we talked about it. That is the wavelength. So already I referred to this one. That is the wavelength. So you see, if you study your diagram, you're not going to struggle to answer these questions. We also talked about this Y, which is the amplitude. So I'm not going to explain much there. We talked about these two. All right. On 2.3, we are given from the above wave, calculate 2.31, the wavelength. From these, calculate the wavelength. All right. According to the information that we are given, because we've got the frequency and also the speed is given there. All right. So that's 2.31. Remember that. Or you need, all right, you need to calculate the wavelength. But we do understand that the speed is equal to what? We are going to have the frequency times what? The wavelength. So we can simply make this the subject by dividing by the frequency. Remember, this formula you are given from your information sheet. So we can make this the subject, which is our wavelength. So at the end, we are going to have the speed over what? Over the frequency. So we are given the speed 10 meters per second, and also the frequency we are having this as 10 from the information that we are given. So that was going to give us the wavelength. All right. So 10 divided by 20 was going to give us 0.5. Remember the units. The wavelength is measured in what? In meters. So that is when you are given this in meters per second, you're going to have this in what? In meters. All right, moving on to question 2.32. That was the time between point A and point B on the graph. All right, the time between these. So if we are to consider what we are given, that is from point A, all right, this is the point A that we are given here to the point B, all right, point A to point B. So as I was illustrating before, if we are to consider this, guys, I want you to see properly on a sine wave. It can be easier this way. If you are given a sine wave like this, all right, this is a sine wave that we are used to. So if we are to consider, this is a half which is going somewhere, this one, all right, this is another half which is going somewhere. So if you are to consider that you are starting from this point to this point, it's a half. What is important is for you to complete it, to say this is being completed with another section like this, to call it what? To call it a complete cycle. So when you are to divide it, all right, when you are to divide it from the maximum value like this, when you are to divide it from the maximum value like this, to this other, like this one, we are moving from this maximum value to the crest like this one. All right, from this crest to the trough, that is this part. It is representing a half. That is, we have got this quarter and this quarter here. That is a half. And we have got a quarter and another quarter to give us a complete cycle. So if you are to figure out, because where this point is starting A, if you are to consider it, this is like this point here. This is where we have our A. We are going to have another continuation. I want you to see, because I'm saying this is going to continue like this. So it was going to continue like this. So I want us to figure out from this understanding, where are we going to have a complete cycle? Because here we had these 1, 2, 3, 4. So you're supposed to have the same thing, just like the previous case, to say this is 1. This one that we are seeing here is 1. Then we are going to have this one that is in between here. Okay, we've got our line like this so that we do not confuse each other. So like this. So this is 1. Okay, this is 2 here. This is 3. Okay, then we have got the fourth one, which is going to be here. So I want you to notice that. Are we seeing that from, if we are to take it properly, from a trough to another trough, like from moving from this trough to another trough like this, you're moving from one trough to another trough. Are you seeing that it is where we have a complete cycle? Because we have got these quarters, 4 of them, 1, 2, 3, 4. You have completed. As you complete the wavelength, you are completing a cycle in that manner, if you understand this. So it's just like this one, because where A is starting, because on our diagram, look where A is, like this. You're going to have it like this. So this one, it's a quarter, this one. Okay, we divide like this. We have got another quarter like this. We have got another quarter like this. We divide it like this. We've got another quarter. So this is a quarter, a quarter, a quarter, a quarter. We have got a full wave like that. What is important is that we are supposed to see this half completed to another half. But in this case, the half that we are seeing on our diagram, so that if you understand that issue of a half to a half, this one on top, I want us to talk about this question so that we correct some of other things that we had before, and also to add information so that you properly understand me. As I explained other videos, I said I'm gonna add more information on question papers. So if you understand this way, that's a half. This one is a half. Where is it starting from? This half. Okay, I want you to see properly. If we get it to the ground, we want to get it to the ground, to the what? Equilibrium position. Are you seeing the halfway it is covering? But if you check from this point A going up like this, we haven't completed a half because this was supposed to be a half like this. It was supposed to be like it was supposed to be, but it is not like that because our A is, yes, we are covering like this. So what is a half of a half? It's a quarter. Half of a half is what? Is a quarter. What is half of a half? That is a quarter. So that is why I was referring in terms of quarters. In terms of quarters, to say this is a quarter, this is a quarter, because of this condition. This is a quarter, all right? We have got another quarter here, another quarter here, and this one is another quarter to make it a complete cycle. If you understand it that way. If you understand it that way, it's up to you. All right. So why am I referring to this issue of a complete cycle? Because we do understand that this part here, the time that we have from point A to B, it is going to consist of the period. So we want to know how many are we going to have, how many complete cycles from A to B, or how many cycles do we have from A to B? All right, so let us answer it that way. Okay, our frequency is there, so remember your frequency. So let us just save it this way. That's 2.32. I hope on this one you understand me very soon. So what I'm simply saying is that we do understand that the period is a condition where we are referring to the time taken for one complete wave. So let's refer to that period. One complete, remember this one. It's from one complete what? One complete wave. That is one we are considering a one complete wave pulse. All right. So that is 1 over frequency. So we can calculate this one. 1 over the frequency, which is 1 over 20. So the period was going to give us what? 0.05 seconds. That is 0.05 seconds. This is the period for a complete cycle. This one that I was referring to say when you consider a cycle, all right? Remember this, from this throw to another throw like this. Meaning to say here we have a cycle which is complete, which is 1. That is 0.05. There with the time there is going to be 0.05 seconds. So meaning to say moving from this point, all right? So because we remember here, we are focused on the throw. From one throw to another throw, all right? So to another throw, we have got another complete cycle, which is 0.05 seconds again. We are going to have the same thing again from this throw to this throw, all right? So there we are going to have another 0.0. That is the condition of the period. The time taken for one complete wave pulse, when it is complete, that is, we've got these 1 over 4, 4 of them, they are complete when they are 4 of them because it will give us 1. So we've got a quarter, a quarter, a quarter, a quarter. That's a cycle. So meaning to say, therefore, the time which is taken from A to B, therefore the time taken from A to B was going to be equal to what? 0.05 plus 0.05 plus 0.05. How best can you indicate that? 0.05 times what? Times 3. There are 3 of them. We have got 3 complete cycles. That is what we can simply say in other words. We have got 3 complete cycles. So 0.05 times 3 was going to give us 0.15 seconds. Just like that. So let us use this information to answer as many questions, try to figure out how questions are given, and to add information on the other questions that we had. Like I said, we are going to add other information because when you're explaining the first part, you'll be like, okay, this can be difficult for you to understand. But for now, I hope we are together. So for now, as you are revising, just take it like this, guys. You won't go wrong. As you refer to a wavelength, where you say there is a wavelength, where you say there is a wavelength. In other words, that distance that you are saying you have got a wavelength, that distance, complete cycle. You have completed a cycle. In that way, you won't have a problem. So in actual sense, we are simply referring to a complete wavelength that is a complete cycle. So using these cycles that we are having to say they are complete, how many of them are we having? How many of them are we having in that condition? So you must work out as many questions as you can. Try to figure out how questions are being given as you are working out. You figure out how questions are being given. That is the way of answering questions. So let's try as many questions as we can.